It's 10:01 and the loyal people are here. I'm looking through this list of people and all of you are very familiar to me now. So thanks for being here on time. I'm going to start by summarizing what we discussed yesterday. So I know for the 9th and 10th graders that yesterday was probably a lot. Looking back, I probably should have structured it a bit differently and derived those rules today. But now we have the rules, and I just want to begin by reviewing to sort of smoothen out the rough patches. So we found that you can transform a function vertically or horizontally. So first of all, we're working in the Cartesian plane, which means x and y, right? And y corresponds to vertical movement and x corresponds to horizontal movement. So vertically, we can dilate things and we can shift things. And to dilate something vertically, you can multiply your function f of x. This arrow means, this arrow is denoted by the transformation. Okay, so don't get confused by these arrows. So to transform something vertically, to dilate something vertically, in other words, to stretch something vertically. So if I have, a smiley face, and if I want it to look like that, this kind of transformation, then I can multiply by some alpha out front. Okay, so I can multiply the entire function by alpha, where alpha, am I recording the lecture? Okay, I am recording. Okay, good. Sorry, where alpha is greater than 1. So how would I stretch something? So if I wanted this smiley face to look like this, what do I need to do to alpha? Let's see here. Matthew, you're the first name I saw. I know you don't have a microphone. Or Lily. I want to hear from some people I haven't heard from. How would I, go ahead.
Wait, what?
Okay, so yes. So
what was your question?
My question is, how would so I know how to get from here to here, from this smiley face to this stretched out smiley face vertically. How would I get from this smiley face, this normal smiley face to this vertically squeezed, right? Here I've compressed this thing vertically. What would alpha need to be?
Less than 1.
Less than 1. Very good. Okay, so these are what we can do vertically. This is how we can dilate things. I hope the smiley face example is appreciated. Now, I can also translate things vertically. And I can do that by adding to the function. So I can add by some number, I'll call it beta. Okay, and if I have a smiley face here, and if I want to move it upwards, what does beta need to be? What does the sign of beta have to be? Let's see here.
Positive.
It has to be positive. Very good. So beta has to be positive because I'm adding to the function. What if I wanted to go from here to here? Pretend these smiley faces are identical. What does beta? Yes, beta needs to be negative. Very good. So you see how the sign of your transformation, either term or factor, determines the sort of nature of the transformation, whether it goes up or down or whether it gets stretched or squeezed. Okay, so these are our vertical transformations, but we can also transform things horizontally. So say I want to, again, the hierarchy, it's not really a hierarchy, but you can either transform things by dilating them, or, in other words, squeezing or stretching them, or by shifting them, translating them. So how would I dilate horizontally? How would I, so in other words, if I had smiley face, how would I get from there to here? This is a horizontal, I guess the eyes would also get stretched out. This is a horizontal stretch, right? How would I stretch this horizontally? Well, we talked about yesterday how I need to multiply this by, instead of multiplying the entire function by alpha, as I did up here. Here now I just need to multiply the inside, the part that is correlated with x, because x, it has to do with horizontal motion. And so if I multiply just the argument x by alpha, then I will get some sort of horizontal change. And here's the tricky part. What does alpha need to be to have it stretched? Greater than or less than 1? Here we had greater than 1 in the previous, in the vertical case. To stretch something, you have to have alpha. Yeah, so for the horizontal case, alpha has to be less than 1. And this was what I called a paradox, yes, or not a paradox, but an apparent contradiction. Because apparently, your intuition would say that, hey, we're treating the vertical direction differently from the horizontal direction, right? Because here, when alpha is greater than 1, you'll have a vertical stretch. In other words, you're making something larger. But here, when alpha is less than 1, you're making something larger. If alpha was greater than 1, you'd have a squeeze. So it seems that there are opposite, that the x and y directions are not being treated equally. But we resolved this contradiction at the end of yesterday's lecture by saying that, no, it's not at all a contradiction. The apparent contradiction lies in the fact that we write functions in terms of x. So you write y equals, you can write any function as y equals something, and x is on this side of the equation, and all the transformations lie on this side of the equation. And so because of that, the transformations for x, if you wrote it the other way around, if you wrote x and the entire function in terms of y, then all the transformations would lie around y. And then y would follow the same rules that x follows in our usual notation. So there's no contradiction in the fact that when alpha is less than 1, you have a horizontal stretch, and when alpha is greater than 1, you have a vertical stretch. So does that make sense? I'm just summarizing sort of what we talked about yesterday, and I'm presenting it slightly differently. Okay, and lastly, we have one more transformation, and that is a horizontal shift, right? Because we had vertical stretch, vertical shift, then we have horizontal stretch. Now we need horizontal shift. And so how would I shift something horizontally? Well, I would say I wanted to shift it to the right. Okay. What does the sign of beta need to be to shift, to go from here to here? In other words, to shift to the right, to the positive x direction. Does beta need to be greater or less than 0? Anyone? Well, we know it's going to be the opposite rule that it is for the y direction, right? And in the y direction, when beta is positive, the thing gets shifted in the positive y direction. So here, when beta is negative, the thing will get shifted in the positive x direction. And when beta is... I might mute everyone because I just heard myself feedback there. When beta is positive, then you have a shift to the left. Okay? So these are our rules, right? I forgot to write the alpha is less than 1, is greater than 1 case. When alpha is greater than 1, you have a horizontal squeeze. Okay, so these are our rules, and you can write them down if you wish. I should have written this below. Okay, so I think this might be helpful for people to copy down because it's very visual and very intuitive. Okay, you see like what's happening to the pictures. Oh, and I erased these. I should not have erased these. Anyway, I hope people copied these down as I wrote them. These are good to know. And on the homework, they are summarized. So I've written it slightly differently here. And I actually, looking back, I should have just written it like this, but it's the same information. So if you forget, just read through these things and you should be able to understand these rules and where they're coming from. So I'm going to leave this up for just a minute so people can write this down because I think it is very worth writing down. So Long said he prefers the words. Okay. So you don't prefer this stuff in green. You prefer the stuff that's typed out.
I prefer the stuff in green.
You prefer the stuff in green. Okay. See, I do too. I think it's, yeah, I think it's way more intuitive. I really felt bad making that worksheet because yeah, we are all different. I don't know about that worksheet. I might rewrite it for future. For whenever people want it again. Anyway, okay, I assume everyone has written this down. So with this, I wanted to review. So people did not do too great on the quiz. I mean, I think the average score was like a 60%, which is fine. I mean, 60 or 70%. It's a quiz. It doesn't matter. It's not going to hurt you tremendously. But I did want to go over the questions that were frequently missed. So I'm going to call on people and hope that they get it right. So for this first one, f of 2x does which of the following to f of x? So I'm going to call on someone I haven't heard from. Ria, I have not heard from you in a long time. Sita Pragna, I haven't heard from you in a while. Tamari, I have not heard from you. Okay, let's see. Alexis said it stretches vertically. So first of all, okay, so Alexis, okay, I'm gonna pick on you a little bit. So when you have, so you are actually correct in terms of the behavior, but okay, and Alexis, did you answer with this one? Dilates vertically by factor of 2. Is that how you answered it on the quiz?
Is it? You're not.
No.
Yes.
No. You did not. So then why'd you say that? That it stretches vertically. Did you answer with this? Okay. So first of all, when you see something of this form, I would look at the rules. So here I have f of 2x. I would look at the rules and first categorize. Is it a vertical transformation or a horizontal transformation? F of 2x. Well, clearly the number, the transformation number, is inside the argument. So it affects the horizontal behavior. So first, I would put myself in this category of horizontal transformations. And then I would say, well, is it a stretch or a shift? And I'd say, well, it's a stretch because it's a multiplicative thing. And then I have this case. And in this case, well, 2 is greater than 1, right? So alpha here is 2, and 2 is greater than 1. And this corresponds, as we discussed, to a vertical, okay, this corresponds to a horizontal squeeze, right? See how the smiley face has been squeezed horizontally? It turns out that a horizontal squeeze is identical to a vertical stretch, but the way it's written here, you should think of this as a horizontal squeeze. Okay. So the answer was, oops, sorry, I did not mean to move everything there. The answer is dilates by a factor of 1/2, right? Because you're squeezing the function. Okay, so I hope that makes sense because many people missed that. 12 people missed it. Okay, how about this one? Let's see, I'm gonna call on someone else. 2 times f of x does which of the following? Let's see. Caleb, I have not heard from you. Kennedy, I have not heard from you. Julia, Jonadab, Brianna, Ascension. I have not heard from any of you recently. Rosie, I've not heard from you. Tanisha, I don't think I've heard from you. Who can answer this? Okay, so Alexis, I guess you just message stretches vertically. Okay, so okay. I'm not gonna wait for people because we have a lot to cover. What does the two, so first of all, is it a vertical transformation or a horizontal transformation? Well, I'd look at these rules and I'd say, okay, well, here, okay, so this is different. Now it's 2 times f of x. And okay, does it fall into horizontal or vertical? Well, it obviously falls into vertical because the factor is outside the function. And it falls into this case because it's a multiplicative thing. And 2 is great, alpha is 2, and 2 is greater than 1. Therefore, it is a vertical stretch by a factor of 2. So it dilates vertically by a factor of 2. Stretch and dilate mean the same thing. Okay, so people did better on that, but I did want to cover. This one was really rough. People really had a hard time with this. So is this a vertical or horizontal transformation? Anyone? Vertical or horizontal? Okay, I did not hear that. I think someone said to the left, but that could be my wishful thinking. Okay, so first of all, f of x plus 1. Well, look, which one does it look like? It falls in this form, right? So it's a horizontal shift, and f of x plus 1, so 1 is beta, and beta, if 1 is beta, then 1 is greater than 0. So this corresponds to a movement to the left, to a shift to the left. See, the smiley face went from here to the left because beta is greater than 0. And so the answer was shifts to the left by 1. And a bunch of people missed that. So this is when I knew that, yeah, yesterday I had not done a good job teaching this. So it's not your fault, it's my fault. Okay, so now does this make sense? Does the behavior make sense? With this knowledge, we'll be able to do a lot. So we're sort of about to be rewarded for everything we've been talking about. Okay, I assume this makes sense. Okay, so let's use what we know and just do a bunch of examples. So I hope you all have a pencil and paper in hand, because we are about to really just start cranking these out. And this is not very helpful if I just do it for you, okay? This is going to be very interactive. Okay, so what is the parent function? And to make it interactive, I will be calling on people. Soliana, what is the parent function?
Y equals x squared.
Yes, very good, thanks. So this is my parent function. And if I could just stick with you, what should my first move be now to make it look like this? So I'll plot y equals x squared for you.
Translate it 2 units up.
Okay, so I could do that. Generally, though, we like to work from inside to out. And this is a subtlety I didn't talk about yesterday. But generally, we like to work as close from x. We start there and
Divide by 3.
Yeah, so first of all, okay, so this is the order of the transformations that I would, so I didn't talk about the subtlety, but generally it is wise to work from as close to the x as you can outward. So if I have, a bunch of things, you remember PEMDAS, right? Your order of operations. This is sort of related. The order we want to do these transformations is in the order of PEMDAS. So this is a statement of addition. So that's here in PEMDAS. And this is a statement of multiplication, and that's here. So we like to multiply things before we add. And generally so the first step, you got the first step of writing the parent function. And now I would plot this because that's closest to x, okay? And what that's going to do is stretch the thing vertically, right? So this is x squared, and now this is 3x squared. And now I can do what you suggested and tack on the vertical shift of +2. And that's going to shift the entire thing up. 2 units. So if I were keeping track of these points, this is the vertex 0, 0 of the parent function, 1, 1, 2, 4. So 3 points, it's good enough. For 3x, this is now the point 1, 3, and 2, 12. And now if I shift it up all to, and this is also the point 0, 3. Sorry, no. For 3x, it's just 0, 0. And now when I add the 2 up, when I add this to this last step, the vertex becomes 0, 2. This point 1, 3 becomes 1, 5, and 2, 12 becomes 2, 14. So in this way, I can keep track of the points and just based on the transformations. But really what we're going for more than the points is the shape. So put a few points on your graphs, but don't draw like 100 points, just enough to really get the shape of the graph. That's what we're really looking for. Really look for the y-intercepts and any zeros. Y and x-intercepts are very important. Okay, good job. Thanks, Soliana. So does this make sense to everyone? Oops.
Yes.
Great, thanks. I like verbal feedback. Okay, I'm going to call on someone else. Let's see, Nishan. I haven't heard from you today. What would be the first step in doing this? So what's my parent function?
Y equals x squared.
Very good. Again, so thanks for, I know that's not Nishan, but thanks anyway. And same person, I can't see your name because I don't have that feature here, but what would be the first step? This is very similar to the last problem. So I'll plot the parent function. How should I go about getting to this? Same person or anyone? So Nishan said, okay, Nishan, you yes. So we got that from someone else. Can you tell me in the chat what I should do next? Do I add 1 as we previously advised against? Flip the parabola over the y-axis. Very good. So Ria, thank you. But it's also more than that, because when you flip it, you also have to stretch it vertically, right? Because of this 5. If the problem were this, then you'd be absolutely right. And then that's all you'd have to do. But because of this 5, this is going to stretch the thing vertically as well as flip it. So here's my parent function. Sorry. Here's the parent function. And now it's going to get flipped and stretched. Oops. Flipped and stretched. So see how it's steep. Oh my gosh, this is bad. It's a lot steeper now, right? See here it was very shallow. Now it's a lot steeper. And now what do? Now I just have to add by 1. So the entire thing gets shifted. I really should use different colors. I'll start using different colors in the next bit. Good. So your vertex is, 0, 1. And you could track some other points. They're all pretty straightforward. Anyway, I think this would be like -1 square root of 5, 0, and I think that's right. Yes, yeah, these are the zeros. So I'm kind of doing this in my head, but you really don't need to put the zeros. I think on the homework I said to, but it's okay if you don't. Just really, we're looking for the shape. So this is your final answer here. This one. Okay, so does that make sense? Things are going to get more sophisticated in just a bit.
Yeah, that made sense.
Great, great. Okay, so now I have a little bit more going on. What is the parent function?
Y equals x squared.
Again, y equals x squared. And so here it is. And this time we'll use different colors. Okay, now what do I do first? What is closest to x? Anyone? Is it the 4 or is it the -1?
-1.
-1. And what does that do? Is that, first of all, that's a horizontal shift, and does it shift it to the right or to the left?
Left.
Okay, so now we have to be careful, because if we go back to our rules, and I will, because if we go back to our rules, so we said that, okay, this is a horizontal transformation, and here it falls into this category, f of x plus beta, and here beta is negative. And when beta is negative, we said that the thing gets shifted to the right. Remember that the rules appear to be opposite for x as they are for y. So it actually does not shift to the right, it shifts to the left. Oh wait, sorry, did I say that right? Okay, it does not shift to the left, it shifts to the right because it's a minus sign. That's how the transformations go for x. And that's out. If you're confused by that contradiction, go back to yesterday's lecture, it's on YouTube, or go through the homework, and it is clear, the contradiction is resolved well in the homework. As to why the transformations appear to go in the opposite direction for x as they go for y. But this -1 shifts the entire thing to the right by 1 unit. So I'll use red for that transformation. So look, the entire thing got shifted to the right. This was horrible. Sorry, people, I'm having a hard time graphing this. There. So the entire thing got shifted to the right by 1 unit. And now what do? Now I can add this 4. And that just moves the entire thing up 4 units. So, oops. See? So all these points got moved up 4 units. It's not really to scale or anything, but so does this make sense? And if I wanted to, I could find these points. I could find what this is, using these transformations. And that's actually really easy. Let's do it. So the vertex here, the original vertex is obviously 0, 0, and then it became 1, 0, and then it became 1, 4. So that's the I should have written that in blue. Anyway, that's the vertex, and then this, the 0, the new y-intercept, it's a little bit trickier. I think it's no, it's just 4. It's literally just 4. Yeah, this is the point. Is that right? Anyway, okay, if you wanted to find this, you could find this. You could expand this thing. I'm having a hard time thinking through this. But anyway, what I really want to talk about is the shape. Okay, so this makes sense.
Yes.
Great. Okay, someone else. What is the parent function? Should not be hard at this point. Let's see, Long, I have not heard from you.
The parent function is x squared.
Very good, just like the other examples. And so I'll draw x squared. And how am I going to manipulate this Long to get, how am I going to manipulate x squared to get into this form? What is the first step? What is closest?
Excellent question. It's going to go down by 10. Or, sorry, up by 10, sorry.
So you're looking outside to in, but I want you to look inside to out. So what is the closest transformation to x?
It's going to translate to the left by 3.
By 3, very good. Yeah, great. So here's the 3, and here, left 3. Okay, that was bad, sorry. There we go. So it moved to the left 3. And now what? Now what's the next sort of thing that's closest to x?
And now we're going to, what's it called, mirror it?
Sure, great. So I'm going to do that in green. So now the entire thing just gets flipped.
Yep.
And now what?
And then it's going to, translate up by 10.
Up by 10, great. And so this is your shape. Okay, and it shouldn't have shifted quite so much. There we go. So the entire thing then it gets moved up by 10. And again, if you want, you can map what these points are. So this was the vertex 0, 0, and it became -3, 0, and then it became -3, 10. And you could similarly, find the other intercepts here. But anyway, yeah, great. So okay. So I think people are catching on. Great job, Lon. Okay, someone else. Let's see. I do want to hear Lily. I have not heard from you in a long time. Kennedy, I have not heard from you. Julia, I have not heard from you. Do any of you? What is the parent function of this? Any of the names I just called on can answer. Lily, Julia, or Kennedy? Do any of you know? Do not be shy.
Y equals x squared.
The parent function to this is not y equals x squared, but thank you for participating. It is great to hear your voice. The parent function is not y equals x squared. Do you see an x squared in here? No. But we did talk about this function and how it looks like a v. So this is your parent function. In a sense, the parent function is just y equals x, but we can treat this as the parent function, right? This is pretty well defined. And Julia, what would I do first to transform this into this? What is the closest transformation to x?
2.
Mm-hmm.
Multiply it by 2.
Yep, and so what does that mean geometrically here? Is this a vertical shift, horizontal shift, vertical stretch, horizontal stretch?
Vertical stretch.
Very good. Yes. And for those who don't know why, you can look back under our rules, and this falls into that category of, f of x becoming alpha times f of x, and alpha is greater than 1, and that's exactly the case we have here. So, great. So now what do I do? Now that I have that, now what's the next transformation, the last transformation? Julia.
Shift it up by 1.
Very good. And so this entire thing got shifted up by 1. And so this vertex is 0, 1. And you could similarly plot all the other points. I'll just do one more. This is point 1, 2. And wait, is that right? Yes, that's right. And this is the point 2, 2. Okay, anyway, you could fill in some other points if you wanted to, but that is very good. That's the general shape of that. So it's sort of a more angled v than the parent function, and it's shifted up by a unit. Okay, slightly harder. And let's see, Jessica, I have not heard from you. Can you help us with this one? What is my parent function here? Okay. I do not hear anything from Jessica. Please, if you don't know, just tell me so we don't waste time just waiting for you. Okay, Fiona, do you know?
The absolute value of x. Is that the
X squared. Okay, good. So really I would think of our parent function. Thanks for participating. I think our parent function would be x squared still. Okay. And here it is. And now, Fiona, what's the first transformation? What's the closest thing to x squared here? The first thing that is affecting it.
The x squared.
So yeah, it's actually the absolute value bars. And we know that the absolute value bars just take anything that's negative and it flips it and makes it positive. And here, is there anything that's negative on this graph?
Yes, the -2 and -4.
Oh, sorry. So looking just at this graph, at the graph of x squared, is there anything negative? Does any part of this graph go below the x-axis? Are there any negative? No, there are no negative y values. So these absolute value bars do absolutely nothing. Okay, and so we can disregard them because they do nothing. And so our next transformation is what? What is closest now, Fiona? The -2, right? That's closest to x. You do that before you do the 4, because 4 in PEMDAS is it goes after, right? So the -2, well, what does that do? Is that Fiona, is that a vertical stretch, horizontal stretch, vertical shift, or horizontal shift? You tell me.
Um,
If you are confused, or if you're not sure, remember that if you have alpha times f of x, and alpha is greater than 1, that corresponds to a vertical stretch. And that's the exact case we have here. So this is going to be vertically stretched, but because of this minus sign, it's going to be flipped over the x-axis. So it's going to look, so the -2, I'll use blue. So for this part, it's going to be flipped over the x-axis. Sorry. This computer, there's a lag slightly, probably because I'm live streaming and recording and all that. Anyway, okay, so -2, so it gets stretched a bit and it gets flipped over the axis. And then this -4 shifts everything down by 4 units. So that's your, sorry, this is a really bad drawing, but that's your final function. Stretched, flipped, and shifted down 4 units. Make sense? So your vertex is 0, -4. That's that point right here. Okay, thanks, Fiona. Let's see. I have not heard from many people. Ascension, I have not heard from you. Can you tell me how I would go about doing this? No. Adi, I have not heard from you. That's strange. I usually hear from you a lot. Can you tell me how I would go about doing this?
So first it would be a vertical, so it would be a vertical reflection because of the negative sign.
So even before that.
Yeah, you can do the insides first.
Yeah, so this,
It's
in this
right 1 and left 2. Right 2, right 1, left 2.
So these things are actually not transformations. So what do you think the parent function is here, Adi?
Absolute value.
It's not, because what is the degree of the inside?
Oh, it's squared, so it's a quadratic.
Yeah, it's actually a quadratic. And so you could think of your parent function as x squared, but you know that when things are factored in this way, we spent 2 weeks on quadratics 2 weeks ago, or we spent a week on quadratics 2 weeks ago. We know that when things are in this form, what are your
just
zeros?
foil it.
Well, you don't need to foil it because this
Oh,
is
yeah.
actually the form you like. So what are the zeros of this function?
It'll be 1 and -2.
And so that is, and does this quadratic in green here, does this thing point up or down?
I would point up.
Yeah, because there's a positive sign here, right? It's a positive thing. And so here's 1, here's -2. And so this is y. This is this inside part. And now if I put absolute value bars, what happens, Adi?
It'll always stay. It will always be above. It'll always be positive.
Right. And so what does that mean? How should I transform the graph then here? What does you're absolutely right, but what happens to the graph?
Oh, so it's x is equal to -2. That would be a +2. So it would go up.
So this -2 becomes a +2. Is that what you're saying?
Yeah.
Okay, that's not what happens because you're confusing the negative x values with the negative y values. The absolute value bars affect the y values, and so the y values here, the negative y values are down here, and these are the ones that become positive. Not the negative x values. The negative x values are not affected by these absolute value bars. So this is what happens. This part of the graph that was negative gets reflected. Okay.
Yeah, and then yeah.
And now what do you do? Now what's out here?
So that bottom little circle wouldn't be there, and it would go the other direction because of the reflection. And it
Exactly.
would
Yeah.
go up.
So just as I've drawn. And now, what does this minus sign do?
Minus sign will reflect it, so it'll
Right.
go the opposite way, and then it's +4, so it'll go up 4.
Yep. And so now I'm going to erase all this. And we know that this was the point. This computer's so slow. Sorry. And we know that these were these corresponding little zeros. And now the +4 will move the entire thing up 4 units.
Yes.
I'll do this with the rainbow pen. Yeah, so these sharp points have, using our transformations, these sharp points have the coordinates 1, 4 and -2, 4. Great, good job. So that was a harder one, but you rose to the occasion. So it looks like it looks like a bat. It almost looks like the Batman bat to me. I don't know. Anyway, I hope this makes sense to people. Let's do a few more. Okay, I'm going to walk people through this one. So my parent function here is e to the x, and we talked about how that's the exponential, right? And now the closest thing to the x here, using PEMDAS, is the 2. See, 2 times e. And so all that does, that follows the case of f of x transforming to alpha times f of x, where alpha is positive, is greater than 1, and so this corresponds to a vertical stretch. And so stretching this thing vertically gives me something like that. So that's what the 2 does. And then adding 1 makes this entire thing shift up 1 unit. Okay, that was really bad.
And it has that horizontal asymptote.
And it still has the same, well, sorry, it does not have the same horizontal asymptote. The horizontal asymptote is also shifted up.
At y = 1.
Yeah, at y = 1. That's a really good point. So for the,
It's
I guess
lagging for me really bad.
it's lagging for you really bad.
Yeah, it will. It's fine. It doesn't really matter.
Yeah, sorry. Can you at least hear me? Whoever said that?
Honestly, it's
Yeah.
better
Okay.
because like it takes a while, and then like it loads the entire line by itself.
Oh, I see. Okay, well, sorry for the lag. Yeah, I don't think there's anything I can do about it. So sorry. So this is the asymptote y is 1. So that's a great point, Adi. Thanks. To keep track of your asymptote. So the first asymptote was y = 0. Your new asymptote is y = 1. So this is really a subtle point for the 11th and 12th graders. The 9th and 10th graders don't really know what asymptotes are yet, formally. But anyway, okay, good. So this was a good little example. So eventually, I remember when I was learning how to do this stuff, it used to take a really long time to think through the transformations. And I remember my 10th grade Algebra 2 teacher doing it super quickly. And she would just, oh yeah, okay, so then times 2 plus 1, done. But that speed is where you eventually want to be, okay? So here, I'll do this one as well. My parent function is e to the x, okay? And that looks like that. And then this minus sign, well, that reflects, that makes all my net. So Adi, remember when you were taking the absolute value of that last example and you thought that the thing was affecting the domain, but it was affecting, here, this minus sign truly affects the domain. So this minus sign reflects all the negative x values across and all the positive x values across. So the minus sign, I'll do this in red. What this minus sign does is gives you the mirror image across the y-axis. And then the +1, lastly, this +1 here shifts everything up a unit.
It also has a horizontal asymptote.
Exactly, at y =
1.
1. Yep. Okay, great. So let's just do a few more. So this one's similar. It's just a composite of the last two ones. My parent function is e to the x, and I'm not even going to draw the parent function now because I sort of have this in my head. This is going to shift the parent function to the left 1 unit. Okay, maybe I will draw the parent function just so people are not confused. The minus, this +1 shifts the graph to the left, like so. The entire thing gets shifted to the left. The times 2 stretches the entire thing. Okay, so it's going to get stretched by a factor of 2, right? And now this -1 moves this new blue graph down a unit. So my new asymptote is going to be y is
Negative
-1, and it's going to look like that. So again, I'm just looking for the general shape. I'm not as concerned with the points and stuff. But I hope this makes sense, just the thought process. I kind of did that fast to show you how I would do it if I were just by myself. Okay, there were more examples, many more examples, I think. I do want to do one with the natural log because I have something fun to show you all before you take the quiz. Okay, so natural log of x, we talked about its shape, and it looks like the inverse of the exponential. So the exponential looks like this. The natural log is reflected across the line y equals x. And so this is ln of x. That did not draw. There it is. That's the natural log of x. And now my only transformation is this +1, right? And so the +1 just moves this entire graph up a unit. And that wasn't quite up a unit. So it'll look like that.
And its vertical asymptote is at 0.
What's that, Adi?
Vertical asymptote is x equals 0.
Very good. And that's the same for both graphs because there is no horizontal transformation.
Yeah.
Great. So this one is slightly more involved. I don't know if I should call on someone or if I should just do it. I think I'll just do it for the sake of time. My parent function is the natural log of x. So why is this thing not writing? That's the natural log of x. And now I'm going to multiply that by 2. That's a vertical stretch, right? And then I'm going to shift it down by 1. Vertical shift. So I'll do this in red, right? And then taking the absolute value bars, all my negative stuff, so I'm looking just at the red graph now, everything that was negative will become positive. So all of this stuff here, that's going to become positive.
It kind of looks like 2 V's.
Just one V, right? Where'd you get 2 V's from?
Isn't there one on the other side as well?
Isn't there one?
There's no asymptote in this one.
Whenever you have natural log of x, there should be an asymptote. Are you looking like at a grapher? Did you graph it online?
No, I'm just saying. I graphed it on the paper, and that's what I got.
So there should, if you put in a negative x value here, the natural log is not defined for negative x values. Right? We talked about this because remember how e to the x. So this statement is the same thing as e to the y is x, and you cannot have. You can search the universe for different y values to give you a negative x value, and you'll never find one. You can put in negative y values, you can put in imaginary y values, you can put in fractional y values, and you'll never find a negative x value. And so therefore, the natural log is not defined for negative x value. So I know that it can't exist on this side of the graph.
I just put it in the grapher, and like it's 2 of the V's.
It's 2 of the V's.
Yeah. The first V goes all the way to 0, and then it bounces out.
Did you put the absolute value bars on the outside?
Yeah. It's absolute value 2 ln x minus 1, absolute value close.
That's very strange. Okay, let's talk about that right after. If you can stick around, Adi, let's figure out what's going on. I don't think that's right, but if you're using a grapher, it must be right. Okay, I think we've covered. I had some more examples, but I think we have covered sort of enough to get you through the quiz. The quiz addresses some of the things we talked about yesterday. So it is going to test your memory. Okay, and I'm sending it out. I'm gonna mute this. So, because there's some background sound. Okay. Okay, so I'm about to send out the quiz. Patricia's office hours are today, 1 p.m. I think. Let me actually text her. She might have moved to 2 p.m. There's the quiz. Remember that the homework is due Friday. It's online. And Audie, if you want to stick around.
Yeah, I'm here.
Okay, cool. So I'm going to share my screen with you. Let's see here. Okay, can you see my entire screen now?
Yeah.
Great. Okay, so I'm going to go to Desmos and let's see what's going on here. I appreciate you putting this in. So if I just had natural log of x, it's this nice thing, right? And the absolute value of that thing, see how the absolute value just took the negative part
Yeah.
and flipped it? So that makes
It's also
sense.
2.
Yeah, and so now the 2 and then minus 1. So this is what I'm getting. And that's pretty much what I drew. So I'm not sure how you
My
got.
grapher must be doing it wrong.
Yeah, I have a feeling because you can't, natural log doesn't have negative x values. But you know what, what I have a feeling your grapher is interpreting is this. Let's see.
No, it's definitely it's like it's the exact same thing except I put a parenthesis around the x. So
Okay.
I don't know. It's just maybe it's that thing is just wrong.
Gotcha. Okay. This is strange though. This as well. I'm not sure. Why is this not correct? This is very strange. Yeah, sometimes these graphers do weird things with absolute value. See, this is not. This should still plot something, right? Absolute. Why is it saying? Okay, they want parentheses. Like that's gonna help. Okay, there we go. That's what I wanted. I needed parentheses. Yeah. So is this what your grapher gave you? Something like this?
Yeah.
Yeah. So it just must be interpreting absolute value wrong. Yeah. Anyway. Okay. Well, thanks for asking. Anyway, that was still helpful. Okay, people, I'll stick around for a few minutes, and I can answer any questions that you have about the quiz or homework.
I have a question on the homework.
Go ahead. Yeah.
So, they're not really numbered at the beginning, but I just named them like 1, 2, and 3.
That's fine.
I believe it was when it said, let me look for it because I lost it. For the graph where it's y equals x squared plus 1, I filled it out, and then on the next one, it's going to be the same thing. Since it's y minus 1 equals x squared, do I fill it out again?
Yes, you do fill it out again.
Because it says graph this below and verify that it is displayed in 1 above y equals x squared. So do I do the same thing as the top one? Because that's
it's the exact same. Yeah, it's the exact same thing.
It's the exact same thing. Oh, okay.
Let's see what I actually asked you to do. Let's see. I said do not solve the right-hand column for y. So the table itself is not going to be the same thing. The table itself.
Thank you so much.
Yeah, you're welcome, Adi. Let's see the table. Are you looking at the screen I'm looking at here?
Yes.
Okay, great. So in this table, let's see here. What was I asking you all to do? Here I wanted you to write what y equals. Yeah, I don't want you to solve the right-hand side here for y. So the values of this table will be x squared. Right?
Oh,
So this will be like 4, 1, 0, 1, 4. And then let's see. Well, one sec. I could be telling this to you wrong. I wrote this in a very like deliberate way, and I want to make sure I'm. I said instead, ask yourself what value does y need to be to satisfy the equation,